the first step for anything, draw the picture, write down what you know. The average 88 kilometers per hour. It stops for 24 minutes. And then it travels another 210 kilometers. The average is 75, and this is south, kilometers per hour south. Okay. And you need help on both parts?
Yeah, I did.
Okay. So, how long is the whole trip? Okay. Delta T equals. All right. Well, there are a couple in this stop here. Oops. Stopped for 24 minutes. Okay. So, the first thing to do is figure out how long they're driving for part 1 and how long they're driving for part 2 and add them up. So our total time, remember that velocity is delta x over delta t. Can you solve for delta t knowing those two? I think you can. So what's the rearranged equation to solve for delta t?
Delta x divided by v.
Delta x divided by v. Good. Delta t equals delta x divided by v. Okay, so you can get that for both parts of the trip, add them together, and now you've got the total time for the trip, right? Huh? And you have to add that in, right. It'd be nice if our stops didn't count against us, but they do.
How do we know, like, what metric? Like, when we're doing
Yeah, what would you want in this one?
Okay, we're going to look at page 47, number 1. So, if I tell you that, here, there's the position of object number 1. If I tell you that object number 2 is 5 meters away from it, does that tell you where object number 2 is? Why not? Yeah, you have to be more specific than that. You know, we need to know a direction. We need to know some kind of. There has to be some sort of context for that. Does that make sense? 5.50 minutes. 1 minute. 60 seconds. At that point, we're actually ready to solve. So you guys can take it from there, I think, right? But the very good reason to do it this way, to, think about the relationship algebraically, create expressions, and plug them in, is because that's what you're going to keep doing and doing and doing and doing and doing. Okay? All right, so we should have that one covered.